This is the EdExcel Advanced Extension Award in Mathematics from the June 2025 series. Question number 1. Using the substitution u equals pi over 2 multiplied by the square root of 1 plus x, we have to evaluate the integral of sec squared of pi over 2 times 1 plus x with respect to x between 5 over 4 and 21 over 4. So we have this substitution u, which is equal to pi multiplied by 1 plus x over 2. And I will rewrite this as pi over 2 multiplied by 1 plus x to the 1/2. We can rearrange u, and in doing so you will find the square root of 1 plus x to equal 2u over pi. We may need to use this later on. Now let us work out what du over dx is. Working this out, we have pi over 2 multiplied by the power, which is 1/2, multiplied by the bracket, which is 1 plus x, to the power of negative 1/2, and of course we multiply by the derivative of the bracket, which is just 1. So we have pi over 4 multiplied by 1 plus x to the negative 1/2, which I will rewrite as pi over 4 times the square root of 1 plus x. Now, if we know what du over dx is, which is pi over 4 times pi, the square root of 1 plus x, we can then state that dx over du is equal to 4 times pi, the square root of 1 plus x over pi. And therefore, dx will equal 4 times pi, the square root of 1 plus x over pi times du. And we already know what the square root of 1 plus x is. That's 2u over pi. And so, substituting that in, we have 4 times pi, 2u over pi, all over pi times du, which would simplify to 8u over pi squared du. We have a lower limit when x is equal to 5 over 4, and with that we can find the corresponding u limit. When x is equal to 5 over 4, we have u, which is equal to pi over 2 multiplied by 1 plus 5 over 4 to the 1/2, which simplifies to 3 pi over 4. This is the lower limit. And for the upper limit, that's when x is equal to 21 over 4. The corresponding u value will equal pi over 2 times by 1 plus 21 over 4 to the 1/2, which simplifies to 5 pi over 4. This is our upper limit. So, we can now rewrite this integral all in terms of u. So we've got the integral, which becomes, well, we've got the integration symbol. Now, we know that inside this bracket we've got pi over 2 times by the square root of 1 plus x, which is what u is. So we have sec squared u. And we multiply this by dx, which we have found to be 8u over pi squared du. And we know what our lower and upper limits are. So for our lower limit we've got 3 pi over 4, and for our upper limit we've got 5 pi over 4. And so we can rewrite this as 8 over pi squared times the integral of u sec squared u du, which we want to evaluate between 3 pi over 4 and 5 pi over 4. We can evaluate this using integration by parts. Now let's just focus on integrating u sec squared u du. If I say that f is equal to u, that means f dash will equal 1. And if g dash is equal to sec squared u, integrating sec squared, we end up with tan. so g will equal tan u. So the integral of u sec squared u with respect to u is equal to u multiplied by tan u, subtract the integral of 1 multiplied by tan u du plus c. So we've got u tan u subtract the integral of tan u du plus c. So we have u tan u subtract the natural log of the mod of sec u plus c. And so we can continue working this out. We have to multiply this result by a over pi squared and use our limits accordingly. So we have a over pi squared multiplied by u tan u subtract the natural log of the mod of sec u, and we wish to evaluate this in between 3 pi over 4 and 5 pi over 4. Now let's just do some early substitution. When u is equal to 3 pi over 4, the tan of 3 pi over 4 is equal to -1, and sec of 3 pi over 4 is equal to -√2. And when u is equal to 5 pi over 4, tan of 5 pi over 4 is equal to 1, and sec of 5 pi over 4 is equal to -√2. So we can continue working this out by substituting all that in. So we have, for our upper limit, a over pi squared multiplied by 5 pi over 4 times the tan of 5 pi over 4, subtract the natural log of the mod of sec of 5 pi over 4, subtract a over pi squared multiplied by 3 pi over 4 times tan of 3 pi over 4, subtract the natural log of the mod of sec of 3 pi over 4. And we've already worked all of this out. So we have a over pi squared multiplied by 5 pi over 4 times by 1, subtract the natural log of the mod of -√2, subtract a over pi squared times by 3 pi over 4 times by -1, subtract the natural log of the mod of -√2. And recognizing that the mod of -√2 is just √2, we have a over pi squared times by 5 pi over 4, subtract the natural log of √2, subtract 8 over pi squared multiplied by -3 pi over 4, subtract the natural log of √2. And what you will also recognize is that the a over pi squared times the negative natural log of √2 and the negative a over pi squared times by negative the natural log of √2 simplified to 0. Then here we've got a negative and a negative which make a plus. So we have a over pi squared multiplied by 5 pi over 4 plus 3 pi over 4. And that simplifies to 16 over pi. Question number 2. Part A. On separate diagrams, we have to sketch the graph of, for the first part, y equals mod of x squared subtract 4, and for the second part, the graph of y equals the mod of x squared subtract 4 subtract 5. We have to indicate clearly on each sketch the coordinates of any vertices and any points where the graph touches or crosses the coordinate axis. So to begin with, here we've got the graph of y equals x squared subtract 4. It crosses the x-axis at -2, 0 and 2, 0, and it crosses the y-axis, which is our vertex, at 0, -4. Now when we mod this, we have to reflect anything underneath the x-axis in the x-axis, and in doing so we end up with this graph here. So here is the graph of y equals the mod of x squared subtract 4. it crosses the x-axis at negative 2, 0 and 2, 0, and it crosses the y-axis at 0, 4. Now, if we have y equals the mod of x squared subtract 4 subtract 5, what we'll do to begin with is we will translate this graph 5 units down, and in doing so we end up with this graph here. So moving the 4 5 units down, we end up with 0, 1. The point here where we've got negative 2, 0 and 2, 0, we've moved them 5 units down as shown, and where that graph crosses the x-axis will be at negative 3 and 3, and we can quite simply work that out by recognizing we have x squared subtract 4 subtract 5, which is x squared subtract 9, and if I set that equal to 0, we end up with x equals positive 3 on negative 3. So this graph is the graph of y equals the mod of x squared subtract 4 subtract 5. And now anything underneath the x-axis we will reflect in the x-axis, and so you can see here we've got the graph of y equals the mod of x squared subtract 4 subtract 5. We've got the vertices shown here, negative 2, 5, 2, 5, and we've got another vertex here, negative 3, 0 and 3, 0, and we've got this point here, 0, 1. Part B, hence solve the equation the mod of x squared subtract 4 subtract 5 equals 1/2 x squared. So you can see here we've represented those graphs. We've got this wider graph, which is y equals x squared over 2, and then we've got this graph in black, which is y equals the mod of x squared subtract 4 subtract 5. And the graph shown here will be negative x squared subtract 4 subtract 5, which is negative x squared plus 9, and the graph here is y equals x squared subtract 4 subtract 5, which is x squared subtract 9. Now the points of intersection will be as follows. We've got the point A, the point B, the point C and the point D. The points A and D is when we have this graph of x squared subtract 9 equaling this x squared over 2. So we have x squared over 2 equals x squared subtract 9. Solving, we've got x squared equals 18, so x is equal to plus minus 3 root 2. And for the points B and C, that's when we have x squared over 2 equaling negative x squared plus 9. So we have x squared over 2 equals negative x squared plus 9. Simplifying, we've got x squared equals 6, meaning x is equal to plus minus root 6. So our solutions will be x equals plus minus 3 root 2 and plus minus root 6. Question number 3. We have to solve the equation the arc sine of 2x equals the arc cos of x subtract pi over 6, where x is in between 0 and 0.5. So, writing out that question, our first step would be to take the sine of both sides. So we have the sine of the arc sine of 2x, which is equal to the sine of the arc cos of x subtract pi over 6. Now, the sine of the arc sine of 2x is quite simply 2x. And on the right hand side, we have the sine of the arc cos of x subtract pi over 6. of course here we can use sine of a subtract b equals sine a cos b subtract cos a sine b. So if I say that this arc cos of x is a and this pi over 6 is b, 2x will then equal sine of a, so we've got the sine of arc cos of x multiplied by cos of b, so that's cos of pi over 6, subtract sine b, so I've got sine of pi over 6 multiplied by cos a, so I've got cos of arc cos of x. So I've got 2x equals, now here I've got the sine of the arc cos of x multiplied by cos of pi over 6, which is root 3 over 2, subtract sine of pi over 6, which is 1/2, multiplied by the cos of the arc cos of x, which is just x. And if we rearrange, then we can add 2x to 1/2 x, leaving us with 5x over 2, and this is equal to root 3 over 2 sine of arc cos of x. And if I multiply through by 2, we would have 5x equals root 3 sine of arc cos of x. What we know is sine squared theta plus cos squared theta is equal to 1. And if I rearrange that, we have sine theta, which is equal to the square root of 1 subtract cos squared theta. And here, what I will essentially do is somehow rewrite this sine of arc cos x. And we can do that by making a substitution of theta equaling arc cos of x, because that's what's in this bracket here. So we've got the sine theta and we've got the sine of theta being sine of arc cos x, where theta is arc cos x. So I've got the sine of arc cos x, which is this bit, which is equal to 1 subtract cos squared of arc cos x square rooted. And recognizing I've got the cos of arc cos of x squared, this will simplify to the square root of 1 subtract x squared. So sine of arc cos x is quite simply the square root of 1 subtract x squared. So I've got 5x equals root 3 times by sine of arc cos of x, so that's the square root of 1 subtract x squared, which we've just worked out. Because we are multiplying two surds together, we can rewrite that under 1 square root. So I've got 5x equals the square root of 3 times by 1 subtract x squared. If I square both sides, I have 25x squared equals 3 times by 1 subtract x squared. And expanding the brackets, I've got 25x squared equals 3 subtract 3x squared. Question number 4. In this question, you may assume that root p is irrational for any prime number p. Part A. Use proof by contradiction to show that there is no rational number a and integer b for which root 5 equals a plus b root 7. As we do with any proof by contradiction question, our first step is to assume the opposite. And if we assume the opposite, that is to say, there is a rational number a and an integer b such that root 5 equals a plus b root 7. If I square both sides, I've got root 5 squared equals a plus b root 7 squared, and therefore expanding and simplifying, we end up with 5 equals a squared plus 2ab root 7 plus 7b squared. Now, if What we now have to do at this point is consider the different cases. We could have A equaling 0 and B equaling 0. And let's see what happens with that. Let's focus on the case where B is equal to 0. So if B equals 0, then we would have 5 equals A squared. In other words, A equals root 5. Now, we know that A is rational. And if we're saying A is rational, that means because A equals root 5, we would also be saying root 5 is rational. And that's false. And that's because root 5 is irrational. And that's using this statement here. Root p is irrational for any prime number p. And of course, the 5 is a prime number, which is why root 5 is irrational. Let's now look at the next case when A is equal to 0. Now, when A is equal to 0, if I set A equal to 0, you can see that we would have root 5, which is equal to b root 7. We would have 5 equals 7b squared. B squared is 5 over 7. Now, what we're saying is, we know b is an integer. So if b is an integer, that means b squared will also be an integer. But we've just found out that b squared is equal to 5 over 7. And this is not an integer. So this is false. And that's because b squared is equal to 5 over 7, which is not an integer. So the case where a equals 0 and b equals 0 gives contradictions, meaning a cannot equal 0 and b cannot equal 0. And if that's the case, then what we can then do is rearrange this equation. And if we rearrange this equation, we can say that root 7 is equal to 5 subtract a squared subtract 7b squared over 2ab. And because a and b do not equal 0, we will not be dividing by 0. So what we've just shown here then is root 7, which is this result here, this is rational. Now, can we have this being rational? Well, no, we can't, because root 7 is irrational, and that's because 7 is a prime. Again, we're using root p is irrational for any prime number p. So we've got contradictions over here. And therefore, we can say then that there is no rational number a and integer b such that root 5 is equal to a plus b root 7. Part B, hence prove that root 5 plus root 7 is not a rational number. So here, let's assume the opposite. In other words, root 5 plus root 7 is rational. And if that's the case, let's say root 5 plus root 7 is equal to r, where r is rational. Now, what we can do is use the result from part A. We know from part A there is no rational number a and integer b such that root 5 is equal to a plus b root 7. So let's rewrite this into this form here. So we have root 5 equals r subtract root 7, or in other words, root 5 is equal to r plus negative 1 times by root 7. And then what you can do is compare with what we have here. First of all, you can see a is equal to r and b is equal to negative 1. Now, if we have a equals r, of course r is rational, and where we have b equals negative 1, well, this is an integer. And what we know from part A is there is no rational number a and integer b such that root 5 equals a plus b root 7. So we know that this result is impossible. And that's what we found in part A, meaning our assumption is wrong, and therefore root 5 plus root 7 is irrational. Question number 5. The discrete random variable x has probability distribution as shown here. We've got values of n and the probability that x equals n, and a and x are constants. Part A, we have to show that sine squared of 2x equals 6 over 7 subtract 5a. Now, what we can do is recognize that probability adds up to 1. So we have to add up each of these probabilities and set the result equal to 1. So, we've got 1 over 10 cos x squared x plus a plus 1 over 5 cot squared x plus 1 over 10 sec squared x plus 1 over 5 tan squared x equals 1. Cos x squared is 1 over sine squared. So I've got 1 over 10 sine squared x plus a. Cot squared is 1 over tan squared. So I add on to this 1 over 5 tan squared x. Sec squared is 1 over cos squared. So I add on to this 1 over 10 cos squared x. And then I add on tan squared x over 5. This is all equal to 1. So I've got 1 over 10 sine squared x plus a, and we know that tan squared is sine squared over cos squared, so 1 over tan squared is cos squared over sine squared, so I add on to this cos squared x over 5 sine squared x, then I add on 1 over 10 cos squared x, and then I add on sine squared x over 5 cos squared x. This is all equal to 1. Now for the trig terms, I want to rewrite this term and this term such that instead of having a 5, I've got a 10. So, to do that, I need to multiply the top and bottom by 2. So I've got 1 over 10 sine squared x plus a plus 2 cos squared x over 10 sine squared x plus 1 over 10 cos squared x plus 2 sine squared x over 10 cos squared x equals 1. And so you can see 2 over 10 is 1 over 5. So, we can group terms together with a common denominator. So we can combine this term with this term. So I've got 1 plus 2 cos squared x over 10 sine squared x. And then I've got this term being combined with this term. So I've got 1 plus 2 sine squared x over 10 cos squared x. And if I take this a over to the right hand side, we will be left with 1 subtract a. So, if I rewrite everything such that I've got a common denominator of 10 sine squared x cos squared x, well here I've got the 1 plus 2 cos squared x. I need to multiply this by cos squared x, and in doing so, we end up with this term. And then, I've got this 1 plus 2 sine squared x. I need to multiply this by sine squared x, and in doing so, I end up with this term if we simplify. And this is equal to 1 subtract a. At this point, we can expand the brackets. So I've got cos squared x plus 2 cos x to the 4 plus sine squared x plus 2 sine x to the 4 all over 10 sine squared x cos squared x, and this is equal to 1 subtract a. So I've got the sine squared x plus the cos squared x plus 2 multiplied by sine x to the 4 plus cos x to the 4 all over 10 sine squared x cos squared x equals 1 subtract a. Sine squared x plus cos squared x is 1, and then I add on 2 multiplied by sine x to the 4 plus cos x to the 4, and sine x to the 4 plus cos x to the 4, that is the same as sine squared x plus cos squared x all squared subtract 2 sine squared x cos squared x. So this result is the same as sin x to the 4 plus cos x to the 4, and we still need to multiply by the 2. Continuing, we divide this by 10 sin squared x cos squared x, and this is all equal to 1 subtract a. So I've got 1 plus 2 multiplied by, now here's sin squared x plus cos squared x, that's 1, and then I'm squaring it. And then I subtract from this 2 sin squared x cos squared x. And divide all this by 10 sin squared x cos squared x. This is equal to 1 subtract a. Let's expand. I've got 1 plus 2 times by 1 squared, which is 3. And then I've got 2 times by minus 2 sin squared x cos squared x, which is minus 4 sin squared x cos squared x. I divide this by 10 sin squared x cos squared x. This is equal to 1 subtract a. What our aim is to show we have sine squared of 2x somehow. Now, what we know is sine 2x is equal to 2 sin x cos x. And if I square both sides, you can see sine squared of 2x is equal to 4 sin squared x cos squared x. So what we can do is replace accordingly. Now, with this result, for the numerator, we would have 3 subtract sine squared 2x, and that's because 4 sine squared x cos squared x is simply sine squared 2x. And on the denominator, I can rewrite this as 10 over 4 times by 4 sine squared x cos squared x. And 10 over 4 times by 4 just gives us the 10. And therefore we can replace this bit with sine squared 2x. And this is of course equal to 1 subtract a. Now 10 over 4 will simplify to 5 over 2. And of course the 4 sine squared x cos squared x gives us sine squared 2x. So I've got 3 subtract sine squared 2x over 5 over 2 sine squared 2x equals 1 subtract a. Let's multiply through and get rid of the denominator. So I've got 3 subtract sine squared 2x equals 5 over 2 times by 1 subtract a times by sine squared 2x. Now everything involving a sine squared 2x let's take over to one side. So I've got 5 over 2 times 1 subtract a sine squared 2x plus another sine squared 2x, this will equal 3. So now if I factorize out a sine squared 2x, I would have 5 over 2 times 1 subtract a plus 1 inside the bracket, and this is all equal to 3. We can rewrite this bracket as follows. We've got 5 multiplied by 1 subtract a plus 2 all over 2, because 2 over 2 is just 1. So I've got 5 times 1 subtract a plus 2 over 2 times by sine squared 2x equals 3. So if I multiply through by the 2 and then simplify what's inside the numerator of this bracket, I would have 7 subtract 5a sine squared 2x equals 6. And therefore, we can conclude sine squared 2x equals 6 over 7 subtract 5a. Part B. Use the result from Part A to find a restriction on the maximum possible value of a. The maximum of sine squared 2x is 1, which means that this 6 over 7 subtract 5a will be less than or equal to 1. If we solve this inequality, we have 6 being less than or equal to 7 subtract 5a, meaning a is less than or equal to 1/5. Now we know a is one of those probabilities. So, as a is a probability, in other words, a is greater than or equal to 0, we can therefore conclude the restriction for a, we would have a being greater than or equal to 0, but less than or equal to 1/5. The random variables x1 and x2 are independent and each have the same distribution as x. Given that the probability of x1 times x2 equals 16 equals a subtract 1 over 25, part C, we have to determine any possible values of a, justifying your answer. If we think about two numbers which multiply to give 16. We could have 4 times by 4, that gives us 16. We could have 2 times by 8, which is 16. And we could also have 8 times by 2, which gives us 16. So what we need to do is consider getting a 4, then another 4. Then we need to consider getting a 2 and an 8. And then we need to consider getting an 8 and a 2. And that's because x1 and x2 are independent and each have the same distribution as x. So the probability that x1 times x2 equals 16 is equal to the probability of getting a 4, then another 4, plus the probability of getting a 2, then an 8, plus the probability of getting an 8 and then a 2. The probability of getting a 2 is 1 over 10 cos x squared x. The probability of getting a 4 is a. The probability of getting an 8 is 1 over 10 sec squared x. So let's use all that. The probability of 4 then another 4, that's a times by a. The probability of a 2 and an 8, that is 1 over 10 cos x squared x times by 1 over 10 sec squared x. And the probability of an 8 and then a 2, that is 1 over 10 sec squared x times 1 over 10 cos x squared x. A times a is a squared. And then I've got 2 times by 1 over 10 cos x squared x times 1 over 10 sec squared x. So I have a squared plus 1 over 50, and that's because I've got 2 times by 1 over 10 times another 1 over 10, which is 2 over 100, which simplifies to 1 over 50. And then I multiply this by cos x squared x sec squared x. So I've got a squared plus 1 over 50 sine squared x cos squared x. And as we used before the result here where we have sine squared 2x equals 4 sine squared x cos squared x, we can use that here. So I've got a squared plus 1 over 50 over 4 times by 4 sine squared x cos squared x. The 50 over 4 times by 4 will just give me 50. And recognising that 4 sine squared x cos squared x is sine squared 2x, and 50 over 4 is 25 over 2, so I've got 1 over 25 over 2. We can rewrite this as a squared plus 2 over 25 sine squared 2x. So I've got a squared plus 2 over 25 times by 1 over sine squared 2x. So I've got a squared plus 2 over 25 multiplied by, now we know from part A, sine squared 2x is 6 over 7 subtract 5a. So 1 over sine squared 2x will be 7 subtract 5a over 6. So I multiply 2 over 25 by 7 subtract 5a over 6. So I've got a squared plus 7 subtract 5a over 75, and that's because 2 over 6 is 1 over 3, and I multiply that by 25, which gets me the 75. Now, what we know is this result, which is the probability of x1 times x2 equaling 16, that is equal to a subtract 1 over 25. So we need to set this equal to 1 subtract 1 over 25, as shown. Now, let's multiply through by 75. So I've got 75a, subtract 3 equals 75a squared plus 7 take away 5a. So we have 75a squared, subtract 80a plus 10 equals 0. And if I divide through by 5, I've got 15a squared, subtract 16a plus 2 equals 0. Let's use the quadratic formula. A will equal negative 16 plus minus the square root of negative 16 squared, take away 4 times 15 times by 2 all over 2 times by 15. And this simplifies to 8 plus minus root 34 over 15. Now, if I think about the numerical value of root 34, well, I know that root 25 is 5, and I know that root 36 is 6. So root 34 will be approximately 5.8. It will be in between 5 and 6, but a bit closer to the 6. So where I've got 8 plus minus root 34 over 15, we can rewrite that as 8 plus minus 5.8 over 15. 8 plus 5.8 over 15 is 13.8 over 15, and 8 subtract 5.8 over 15, that's 2.2 over 15. And what we know is A is in between 0 and 1 over 5. So this 2.2 over 15, that is certainly in this interval. So the value we want is this 2.2 over 15. And we got that by using 8 subtract 5.8. So we have to use the negative root 34, meaning A will equal 8 subtract root 34 over 15. Question number 6. Relative to a fixed origin O, the points A, B and C have position vectors, or A equals 10i plus 5j plus 4k, or B equals negative 4i plus 7j subtract k, or C equals negative 2i plus 17j plus 10k. Let's show those points. We've got the point A with coordinates 10, 5, 4, the point B with coordinates negative 4, 7, negative 1, and the point C with coordinates negative 2, 17, and 10. Part A. Show that triangle ABC is isosceles. We would have to use these points here. So let's begin by finding the vector AB. That's equal to OB take away OA. So we've got negative 4i plus 7j take away k, subtract 10i plus 5j plus 4k, and if we work this out, we get negative 14i plus 2j subtract 5k. So the length of AB is given by the square root of negative 14 squared plus 2 squared plus 5 squared, so that's the square root of 225, which is 15. So that's AB. Let's now find out what BC is. BC will equal OC take away OB, so I've got negative 2i plus 17j plus 10k, take away negative 4i plus 7j subtract k, and working this out we get 2i plus 10j plus 11k. And therefore the length of BC is given by the square root of 2 squared plus 10 squared plus 11 squared, which is equal to the square root of 225, which is 15. So what you can see is AB is equal to BC, and that's equal to 15, meaning ABC is isosceles. So let's join these points up to form a triangle. The circle S lies inside triangle ABC such that each side of the triangle is a tangent to S. The centre X of S lies on the angle bisector of each vertex of the triangle. So that's what we see here. And then we know the point D lies on AC such that AD is equal to AB. So here is the point D. For part B, we have to find the position vector of D. To begin with, let's find the length of AC. To do that, we need the vector AC. So that's equal to OC take away OA. So I've got negative 2i plus 17j plus 10k take away 10i plus 5j plus 4k. And working this out, we get negative 12i plus 12j plus 6k, meaning the length of AC is equal to the square root of negative 12 squared plus 12 squared plus 6 squared. That's equal to the square root of 324, which is 18. Now we know that AB, which is equal to AD, that will equal 15, because we know that AB is equal to 15. That's what we worked out in part A. Which means D is 15 over 18, or 5/6 of the way from A to C. And that's what we see here. AD is 5/6 of AC. So OD is equal to OA plus 5 over 6 times by AC. So I've got OA, which is 10i plus 5j plus 4k, plus 5 over 6 multiplied by AC, which is negative 12i plus 12j plus 6k, and this means OD is equal to 15j plus 9k. and that is shown here. Part C. Find the position vector of the midpoint of BD. If I join the point B with D, the midpoint will be over here. The midpoint will be a half of OB plus OD. So I've got a half of the vector OB, which is negative 4i plus 7j subtract k, and we add to this OD, which is 15j plus 9k, and working this out, we get negative 2i plus 11j plus 4k. Let's show that on the diagram. Part D. Hence show that the position vector of x is given by OX equals 10i plus 5j plus 4k plus p multiplied by negative 2i plus j, where p is a scalar constant. What we need to recognize in this question, we will be considering the triangle ABD. The bisector of A will pass through M, and therefore what we'd have here is a straight line. So the angle bisector from A goes through M, meaning AXM lies on a straight line, and that's shown here. To find out what the point X is, what we can do to begin with is find out what the vector AM is. So AM is equal to OM take away OA. So I've got the vector OM, which is negative 2i plus 11j plus 4k. Subtract the vector OA, which is 10i plus 5j plus 4k. And working this out, we get negative 12i plus 6j. And because AXM lies on a straight line, AX is in the direction of 2i plus j, which is a factor of this vector here. Meaning, OX is equal to OA plus AX. So I've got 10i plus 5j plus 4k plus p multiplied by 2i plus j, which is the direction vector of AX. And we multiply by p because we don't know how far up the line AM we are going to find the point X. Part E. Use the angle bisector of vertex B to find another expression for OX in terms of a scalar constant Q. What we know is AB equals BC, which is 15. So the bisector at B will be the midpoint of AN, similar to what we did with this triangle ABD. We would have to find the midpoint of AC, call that point N, and the bisector will join B, X and N together. So as AB equals BC, which is 15, we're going to let the midpoint of AC be N. And that's shown here. And we can find that midpoint N. That's equal to a half of OA plus OC. So we've got a half of OA, which is 10i plus 5j plus 4k, plus OC, which is negative 2i plus 17j plus 10k. So we've got 4i plus 11j plus 7k. And that is shown here. As we did before, the angle bisector from B goes through N, meaning BXN lies on a straight line. And here is that straight line. So let's find out what BN is, and as before, we can find a vector for OX, but this time in terms of a scalar Q. So Bn is equal to On take away OB, so I've got 4i plus 11j plus 7k, take away negative 4i plus 7j subtract k, and that means we get 8i plus 4j plus 8k. Which means then, Bx will lie in the direction 2i plus j plus 2k. If I multiply this by some constant, I get the vector shown here. And that's because Bxn lies on a straight line. the vector OX will equal OB plus BX, so I've got negative 4i plus 7j subtract k plus q multiplied by 2i plus j plus 2k. Part F. By equating the k components of the two expressions for OX, determine the value of q. What I need to do is compare this equation with this equation. And if I look at the k components, here I've got 4k, and here I've got negative k plus 2qk. So if I compare the two equations and look at the k component, we would have 4 equals negative 1 plus 2q, meaning q is equal to 5 over 2. For part G, for the first part, we have to find the position vector of the centre of S. That just means find the point x. So OX we know is OB plus BX. That's what we have over here. So all we need to do is replace this q with 5 over 2. So I've got negative 4i plus 7j subtract k plus 5 over 2 times 2i plus j plus 2k. And if I work this out, we get I plus 19 over 2j plus 4k. And that's shown here. We've got 1, 9.5, which is 19 over 2, 4. We now have to find the radius of S. Now we've got the centre, we've got a point which lies on the circumference, that's the point N. We can find this radius by using 3t Pythagoras. So I've got the radius, which is equal to the magnitude of the vector xn. So I've got 4 take away 1 squared plus 11 take away 9.5 squared plus 7 take away 4 squared, which is equal to 4.5. So my radius is 4.5. Question number 7. Given u equals y to the x, part A, by taking the natural log of both sides, or otherwise, determine du over dx in terms of x, y, and dy over dx only. We begin with u equals y to the x, and if we take the natural log of both sides, we've got the natural log of u equals the natural log of y to the x. And using the power law of logs, we can rewrite the right hand side as x multiplied by the natural log of y. Now in the question, because we need to determine du over dx in terms of x, y and dy over dx only, that means we have to differentiate implicitly. So differentiating the natural log of u implicitly, we've got 1 over u times by du over dx, and that's equal to, well, if I differentiate x times the natural log of y, I'd have to use the product rule of differentiation. So I've got the natural log of y multiplied by the derivative of x, which is 1, plus x multiplied by the derivative of the natural log of y with respect to y, x. So that's 1 over y dy over dx. So we would have du over dx equaling, well, if I multiply through by u, I have u multiplied by the natural log of y plus x times by 1 over y, which is x over y, times dy over dx. And we know what u is, that's equal to y to the x. So I've got du over dx equaling y to the x, which is what u is, times by the natural log of y plus x over y dy over dx. So in this question we had to differentiate implicitly because we needed to differentiate everything in terms of x. Figure 1 shows a sketch of the curve given by the equation 3y to the x subtract x cubed times the natural log of y equals 0. The curve has a horizontal asymptote y equals 1 and is defined for x being less than or equal to negative a, x being greater than or equal to a, y is greater than or equal to b, but less than or equal to c, where y does not equal 1. And that's because we've got a horizontal asymptote at y equals 1. And a, b and c are positive constants. For part b, we have to determine dy over dx for this curve. We've got this curve 3y to the x subtract x cubed times the natural log of y equals 0. Now, for us to differentiate and find out what dy over dx is, to begin with, I have to find out what the derivative of 3y to the x is. But happily for us, we already differentiated that. And the result of that is shown here, but we still have to multiply by the 3. So I've got 3 multiplied by y to the x times the natural log of y plus x over y dy over dx, and take away the differential of x cubed times the natural log of y. Well, here we'd have to use the product rule. So I've got x cubed times by the derivative of the natural log of y with respect to x, which is 1 over y dy over dx, plus the derivative of x cubed, which is 3x squared, multiplied by the natural log of y. And differentiating 0, we end up with 0. So expanding and simplifying, we've got 3y to the x times the natural log of y, plus 3x y to the x over y dy over dx, take away x cubed over y dy over dx, subtract 3x squared times the natural log of y equals 0. Now, if I factorise out a dy over dx from this term and this term, and noticing we've got a common denominator of y, we would have 3x y to the x subtract x cubed all over y times dy over dx. And if I take the term here and here to the right hand side, but factorising out a 3 times natural log of y, we would have on the right hand side 3 times natural log y multiplied by x squared subtract y to the x. And so, to find out what dy over dx is, we would have to multiply through by y and then divide by 3x y to the x subtract x cubed. So dy over dx is equal to 3y times the natural log of y times x squared subtract y to the x over 3xy to the x subtract x cubed. Part C, we have to find the value of a. What we know from the question is we've got a horizontal asymptote at y equals 1. And where we'd have this negative a and this a would be the vertical asymptotes. And the vertical asymptotes occur when dx over dy equals 0. So our first step would be to find out what dx over dy is. And that's the reciprocal of this, which is 3xy to the x take away x cubed all over 3y times the natural log of y times x squared take away y to the x. So, for the vertical asymptote, we know that dx over dy equals 0, and setting this equal to 0, we have the following equation. So we've got 3x y to the x subtract x cubed equals 0, and if I factorise out an x, I've got x multiplied by 3y to the x subtract x squared equals 0. Now of course, x cannot equal 0, which means I would have 3y to the x subtract x squared equaling 0, and from this, y to the x is equal to x squared over 3. I'll call this equation 1. Now if I look at my original equation where I've got 3y to the x take away x cubed times the natural log of y equaling 0, I can replace the y to the x with x squared over 3. So I've got 3 times by x squared over 3, subtract x cubed times the natural log of y equals 0. So I've got x squared subtract x cubed times the natural log of y equals 0. And if I factorise out an x squared, I've got x squared multiplied by 1 subtract x times the natural log of y equals 0. So, we've got x squared which doesn't equal 0, and that's because x doesn't equal 0. Or we've got 1 subtract x times the natural log of y equaling 0, which I will call equation 2. Now, if I take a look at this equation 1, what I can do is take logs from equation 1 on both sides. And if I do that, I would have the natural log of y to the x equals the natural log of x squared over 3. So, using the power law of logs, I've got x times the natural log of y equals the natural log of x squared over 3. And if I rearrange this equation, I would have the natural log of x squared over 3 subtract x times the natural log of y equals 0, which I'll call equation 3. Now, if I compare this second equation with this third equation, can you see I've got a 1? Here I've got a natural log of x squared over 3. I've got a minus here, and I've got a x times natural log of y here and here. And I've got an equal 0 here. So if I compare those equations, we can then state that 1 will equal the natural log of x squared over 3, which we can solve. So I've got x squared over 3 equals e to the power of 1. So x squared equals 3e, meaning x equals plus minus the square root of 3e. And that is what the value of a is then. A is equal to square root of 3e, because these values I've just worked out here are my vertical asymptotes. Part D, find the value of B and the value of C. Of course, in this question now, we have to look at the horizontal asymptotes. And for horizontal asymptotes, dy over dx equals 0. And we already know what dy over dx is, we worked that out in part B. So if we set that equal to 0, we have the following equation. So, we've got 3y times the natural log of y times x squared subtract y to the x equals 0. So, I've got 3y equaling 0, meaning y cannot equal 0. And that's obvious by looking at the graph. Then I've got the natural log of y, that can't equal 0. So I've got x squared subtract y to the x equaling 0. And from here, y to the x is equal to x squared, which I will call equation 4. And what I can do now is substitute that back into the original equation. So, I would have 3 times by x squared, because x squared is what y to the x is, take away x cubed times natural log of y equals 0. Factorising out an x squared, I have x squared multiplied by 3 subtract x times natural log y equals 0. Of course, x doesn't equal 0, meaning I'm left with 3 subtract x times natural log y equals 0, and from this, x times natural log y equals 3, which I will call equation 5. And if I take a look at this fourth equation, let's take logs of this. And doing so, I've got natural log of y to the x equals natural log of x squared. So, using the power law of logs, I've got x times natural log y equals natural log of x squared, which I will call equation 6. We can now compare equation 5 and 6. We've got x natural log y, x natural log y, we've got 3 here, and the natural log of x squared. So, by comparison, the natural log of x squared will equal 3. So, I've got x squared which is equal to e to the 3, meaning x is equal to plus minus e to the 3 over 2. And if I take a look at the fifth equation, what we can say from here then is the natural log of y is equal to 3 over x. And that's simply rearranging. And what I know what x is, that's plus minus e to the 3 over 2. So I've got the natural log of y, which is equal to 3 over plus minus e to the 3 over 2. So that's the same as plus minus 3e to the negative 3 over 2. And because that's equal to the natural log of y, if I antilog both sides, we can then state that y is equal to e to the power of plus minus 3e to the negative 3 over 2. So b is equal to e to the negative 3 e to the negative 3 over 2, and c is equal to e to the 3e to the negative 3 over 2.